I guess if we were to go to Elon Musk kind of story, I mean, he really tries to find a working like business model to start with, and then do the research, rather than do the research and then try to find the business model from it. That's kind of an interesting difference, right?
But he seems to really understand what business is. I think he manages to, I mean, change the world with his companies and make money.
And okay, so you worked at Rise before, and then you had the idea you should start your own company. How did that come about? Did you just speak to some friends? And
no, I've always been interested in, or not always, but since I became an adult, interested in starting companies. And I previously worked at Fishbrain, which is a Swedish company that's basically like Instagram, but only pictures of men holding up fishes. But I looked around the Swedish startup ecosystem, and it was the biggest social network in Sweden. So, worked there as their first data scientist.
Actually, it's a very cool company. I listened to their pitch in 2016.
Yeah.
When they were just founding it and etc. And I found it very, very astonishing and very thoughtful, actually. And they had like a lot of users.
Yeah.
So it's basically a Facebook for fishermen. That is what it is.
Yeah, I'm trying to understand. I'm grew up on countryside as well.
So imagine now you have like a social platform. Actually, you can explain this better. Why am I explaining it?
Yeah, well, I mean, it's really, to me, it is a combination of like a utility and Instagram with men holding up fishes, right? Yeah. But the utility part is that people log where they fish, so you can kind of get a sense of where what species are where,
so you
and
get some
when,
ideas of where to go fishing in some sense.
And I'm sure they have like developed a lot since I worked there with, tools and bait and whatnot.
And what was the business model then at that time? Was it simply some ad based or
easy money?
Really?
Yeah, they took in a lot of money
for a social media.
Yeah. So, but I mean, it was the biggest social media company in Sweden, and for like this niche. So I guess the theory from the VCs was that like niche social networks will be a thing, like Strava and Vivino for wine, and then there's a lot of these verticals. But in the end, I mean, you have to make a lot of money to support a lot of a really high valuation. So it's definitely hard, I think.
Okay, so your own company that you started, did you have a name for it, by the way?
Oh, Buildtail was the name for the company.
Buildtail?
Yeah, exactly.
Was it some AI-based thing as well?
No, it was more, I mean, we built a digital platform. But again, I think one learning there was spend less time programming, more time on the economy.
You would hope, I mean, I'm a technologist and tech nerd as well, and you would hope that it wouldn't be necessary to have some, economical experts joining, but in reality, you do, right?
Yeah, and especially if you're working in the real world, like we needed to move goods around and stuff like that. I think that's maybe harder than pure tech. But also a learning is go close to your core interests. I'm really into AI, so maybe the construction world wasn't for me either.
Yeah, very surprised to hear you go that direction. But yeah, I guess that's the best advice you can give, like follow your passion in some way.
Yeah, I think so.
Okay, so you tried it for a year, and then you followed your passion and went back to Rise and work with AI and large language models again, right?
Yeah, together with Magnus Solgren and other great colleagues.
I know a lot of people from Rise, so they have a lot of great people there for sure. But with that, I'd love to welcome you here, Ariel Ekgren. You're a research scientist and I guess technical lead as well at AI Sweden.
Yeah.
And one of the people behind the GPT SP3 model as well.
Yeah.
And that's something I'm looking very much forward to hearing more about, what the origin was, the story is, and what it really is. So that's an awesome topic, I think, for us to have. But before that, can you just describe yourself? Who is really Ariel Ekgren, and what's your background and interest?
So I'm an engineer from KTH from the beginning. But here it's a bit interesting because I didn't really finish KTH. I quit before taking my master's and started working at different startups. But with that said, I went to engineering physics, and I was interested in AI for a long time. But like before KTH, I did not study math at all. So it was a long road to even start KTH, and I just kept reading on the internet about AI and robots. So I somehow you have like these special interests, let's say it like that. So that continued.
So you had a passion, you wanted to follow that. Did you have any AI course in the engineering physics program?
Yeah, so I think I was maybe the first or the second year that also was able to attend the machine learning master. So that was a good start. But I mean, math, linear algebra is very close to AI as well.
For sure. And awesome. So you finished or did not finish KTH studies, and then you went to some startups, and then did you come to RISE directly, or did you?
No, so the first startup that I went to was actually Magnus Sahlgren's startup, Gavagai. Yeah, so I mean, a big part of AI, both in Sweden and in general is language, right? So most people that have worked with language technology in Sweden have come in contact with Gavagai somehow.
And they switched to, and it took some time before they switched to like deep neural network, right?
Yeah, I mean, when I came there, it was word2vec and word embeddings and all of that. So, but I spent some time there, and then I spent some time at Fishbrain, and then I rejoined Magnus at RISE.
Yeah, right. Okay, so Magnus joined RISE, and then you followed him there.
Yeah,
that's how you ended up at RISE, basically.
Exactly.
Did you work with an interesting project at RISE?
Yeah, we had a lot of interesting projects, but with governmental agencies and companies. And one learning is that data is really hard. I mean, so it's yeah.
Please elaborate. What do you mean? Data is hard.
No, but I mean, without bashing anyone, it's like everyone says, like, we're ready to do AI, right? But and we have lots of data, but then you have this. Maybe it's in the wrong format, hidden away somewhere. And
I can just echo that. I've spoken to so many companies and asked them, "Do you have any data on this?" And yes, we have so much data you wouldn't even believe. And then you come there, and it's not really organized. You don't know how to extract it. You don't know where it really is, and to have some proper training data set up, it's really hard.
Yeah.
Right. Cool. So you worked with some project there. Anything specifically that you can mention during the RISE time? Some projects?
I mean, so we had these various projects, and that was related to specific companies and governmental agencies, but then also the language models for Sweden came along, and that was I mean, the people, I was not one of the initiators, but the people who initiated it saw kind of the need to, like the trend, I guess, in a sense, that these AI models, our machine learning models, are becoming larger, and we need to kind of consolidate our efforts. So then we, in that project, a lot of stakeholders, like everything from Skatteverket to other entities, joined efforts and said, let's focus and try to build a BERT model, I think. Yeah.
And even Peltorion, which I was participating from, and I think that's where we met the first time, at least digitally in some way. Yeah, it was the large language models for Swedish authorities, right?
Yeah, exactly, that's the name.
And, it was some very exciting and 3-year project, national project, funding from government through Benova, etc.
Exactly.
Yeah, fun times. And what happened then after the RISE time?
So, I mean, this was pre-GPT-3, I think. So we started to, at RISE, the Natural Language Understanding Group with Magnus Sahlgren and Amaru Kuba and Evi Gugulu and others. We started building our own frameworks and experimenting with, like, how can we really do this? And RISE was really good in the sense that they had bought some GPUs to, I think, so RISE has this cloud service for experimenting in the north called ICE. Yes. Yeah, so they had some resources there where you could start experimenting. But then I think along came like this deep learning revolution with with force. So yeah.
And when you say deep learning revolution, do you mean more the GPTs of the world, or what do you mean with deep learning revolution?
Yeah, so I guess it's a bit hard to disentangle exactly when what happened, but the BERT models, I mean, is part of the transformer family, but then they weren't really this massive and didn't really show like extreme scaling.
Do you call a BERT model a large language model?
No.
You would at that time, though.
Yeah, you would definitely do it at that time. They were huge, right?
Yes.
But today they're really often like the BERT base model is really a small model, I think.
Just a few millions of parameters.
Yeah, exactly.
What is that? You have to have billions.
Yeah.
Do you have a preferred definition of a large language model?
No, but it seems like it's often like something like GPT-3 or nowadays 4 or ChatGPT, kind of an autoregressive, a bit larger model that's hard to almost run on a single GPU.
Is that the main part you would say? I mean, it's kind of interesting, you know, that they made such a big shift from the encoders of BERT to the decoders of GPT. And still you had the original transformer that had both.
Yeah.
And also the original transformer, which was used for translation, they had also this kind of beam search thing.
Yeah.
Which I find surprising that no one is picking up on. And now they have this kind of tree of thought kind of approaches, which really, in my view, is not that dissimilar from beam search. Would you agree?
Yeah, maybe. But I guess to me, it's more of, I think really the bitter lesson is like, so we have definitely not explored all the architectural variations at all. But in some sense, it's also doesn't almost matter as long as you have like some way of, I think, for language generating and then just enough data and enough compute. You could have all these various things, but they will probably end up being very similar in the end.
If we try to have like a question and try to explore this, I mean, obviously the GPT, the decoder-only kind of architecture made a big change.
Yeah.
And if we try to understand, you know, what do you think? Why did the decoder-only GPT style of architecture really make such a big difference?
Yeah, but I think coming back to the bitter lesson, which is just like data and compute is what really matters. I think maybe it was just that was one of the architectures that we decided to scale, and it has kind of a good compute layout, so it works well on graphics cards. So GPT-2 was kind of first, and then I think OpenAI just decided to go with that.
Yes, perhaps. You know, I was a big favor of the T5 kind of models at the time, and I thought they had a really beautiful, like, both encoder decoder thing. Did you have as well, or?
No, but I remember that.
Why, or at what time?
No, but I this is not a value judgment about the T5, but I kind of never understood it because I thought it was like a mix between BERT and the GPT models, which is probably strength.
True.
But to me, it was also confusing.
Yes. Perhaps. Okay, let's not go to T5, but still, it made a really big change with GPT and the decoder only. Do you think it's more the autoaggressive nature of it that had a big reason for it, or do you think what do you think it could be?
Yeah, I think that's definitely opening up the language as the one interface, I think. So if you don't have to like add extra code or anything to get out the answer you want, that's really powerful when the models get bigger and more general, as to say. So, but I'm not like, it's not the only and one thing, but it's where we ended up, and I think them being able to generate language is really a selling point.
Because some people, and I heard that, I think also from some RISE people, I know that, you know, it's just predicting the next word. is just a statistical model. It's just the probability distribution of what next word to predict, and it's nothing more than that. Do you think that's a good description of GPT?
Yes, but no, but I think it's a great description in the sense that that's really what's going on. It's like what we have had in our cell phones for a long time. It's like autocomplete, but it's autocomplete on steroids. And something weird kind of happens when you get good enough at guessing the next word, because in order to kind of disambiguate or have a good model of the world, you need to know a lot of the world, or you need to have really, really complex statistics. So in one sense, it's a bit of an undersell to say it's just guessing the next word.
Isn't it? I mean, isn't also the human brain also just guessing the next word in some sense?
Probably. I mean, I definitely agree with that idea.
And the human brain is also just statistics in some sense.
Yeah, probably.
So is that then a good description? I'm kind of asking leading questions because I don't think it's a good description.
But it's a very functionally correct. It's a functionally correct description.
But you can say that the human brain is just chemo-electrical signals.
Yeah, exactly.
That's functionally correct, but it doesn't really help understanding the brain.
No, it doesn't at all.
Yes.
No. But I also think it's you should kind of find the right balance, because it's these models and like techniques are so powerful. And it might seem like magic, but so we need to kind of, the functional approach is good to kind of take it down from the magic area, but then we also have to say, okay, but these can really perform almost magic. So I guess where is the, what do you think?
I mean, I'm just trying to, if you take a person that is not technical and they're trying to understand, how does an AI model like GPT really work? I don't think it's useful to say, it's just a statistical approach to predict the next word from a probability distribution. That doesn't help at all, I would say. Then you can ask more, okay, so what is it really trying to do? I think you started in a way that I like, which is it needs to do so much more to predict the next word. I mean, we are speaking word by word in our mouth, so of course we have to have the ability to predict what next word to say, otherwise we wouldn't be able to speak. But the main point is really that the human brain has a way to think in some kind of reasoning way. So let's go to the reasoning part. I think
so this is, but I want to add something before. So I imagine that, so we are speaking word by word, but we also have higher level representations like compound.
Don't you think GPT has that?
Probably, maybe, I don't know. But I think this researcher, he's a Swede, but I don't think he lives in Sweden, Anders Andersson, who wrote the book about the 10,000 hour rule. Like if you do deliberate practice for 10,000 hours, you get really good at something. But in his research, he also discovered that you get like these compound representations. So me as a novice in chess, I see the board one like move at a time, but a pro chess person see like 5 moves as one unit. That's really, I think, what's happening in humans all the time. But I'm not sure that or at least at the last step of the GPT models, they still select one of all the words, right? So it's.
I mean, Jan LeCun, for example, I'm sure you're familiar with him, and he basically says that a decoder-only is also an encoder and decoder. Yeah. Because it takes, syntactic words as input, and it has to first encode it. Then in the middle of all these hundreds of layers in GPT-3 at least, it has to have some kind of high-level representation of the meaning of the semantics, so to move away from the syntactic nature of the text to begin with, and then do some kind of reasoning, if you call that, to, in the end, go back to the syntactic and know what word to say. Would you think that's fair to describe it like that?
So... is that his description of how they work?
He's just saying that even a decoder only is still an encoder and decoder.
Yeah. So I was thinking about Anders Andersson. I think his name is Anders Eriksson. Maybe you can look it up. No. But there is a lot of Jan LeCun. He claims that these models are not. We have the problem with autoregressive.
Yes.
So So can you repeat your
I mean, it's basically, if we think about these GPT models, they are very simple. It's like hundreds of layers of the same thing.
Yeah.
It's not an encoder decoder in terms of how the architecture looks like. It's just 100 layers of the exactly same thing. But still, he says, the first part or the first number of layers, perhaps the first 40 of the layers or 20, are still just encoding the syntax of the input to some kind of semantic understanding, and then later going back decoding that into some syntactic representation and predicting the next word.
Yeah.
Would you agree that is a fair description of?
Probably. Yeah.
And then, so then the question is, let's formulate this as a, I think, very interesting, almost philosophical question. Is reasoning happening in GPT models? What would you answer to that question?
Oh, Magnus will be sad if I answer this the wrong way. No, but I think a bit is the boring answer. So I think definitely a bit. But then if you want to, I think I've really tried to figure out what Jan LeCun is like alluding to when he says we should do more kind of reasoning with these models, and the autoregressive step-by-step is not enough. And it boils down to kind of tree search, like we did in the classical stuff. But we kind of, at this point, don't really know how to say which branch of the tree is good. So I think when you have an ability to explore different branches and select the best one, then you're probably closer to reasoning in a sense that is like human, as powerful as humans.
I mean, as I see it, I would argue that it is not high-level reasoning happening in GPTs, but there is some form of reasoning, as you say, and it's also kind of non-intuitive to say that when you don't have an architecture that supports proper iterative reasoning step by step, which you wouldn't think potentially a GPT architecture supports, I would say that's something at least that I heard someone speak about this that changed up my mind. And for one, they say reasoning happens in 2 dimensions in GPTs. One is simply layer by layer.
Yeah.
Just going through that, they have to do some reasoning each time they move from one layer to the next. Yeah. The second dimension of reasoning is happening in the context window. So the larger context window you have, the bigger amount of reasoning you can perform. If you have a super small, context window, like 10 words or 10 tokens, it's very hard to do some proper reasoning. But if you increase the context length, if you increase the number of layers, you get increasing number of or abilities for reasoning. Yeah. Would you say that's fair to say?
Yeah, I think that's a really good characterization. But then if you think of these models as estimators of like functions or algorithms, then it's like, so if you just go height or depth wise, then you kind of quickly reaches the limit. You can't have a loop, basically. You can't really perform like any computation. Yes. You have to have a finite, like an end to it. But then, so we kind of know that there is a limit in that direction. But if you go lengthwise, you would want to add these kind of compute tokens. But then the way we train the models aren't sufficiently good. So there is this claims that this chain of thought reasoning kind of might just give the model extra compute to actually do other algorithms, and I think that might be true or not.
Could we jump to? I mean, it was a big. You don't like this discussion?
No, I love it. Yeah.
But there was a big controversy like 2 weeks ago. When Sam Altman was fired, and then they put in another CEO, and they fired that person. They put in a second or a third, and then he came back and whatnot. Yeah. But one of the potential motivations for the board to fire Sam was that they had added something called a Q-star, something kind of, this is actually what I did my PhD in like 20 years ago. I never thought that would be, active again. But still, they added. Okay, let me phrase the question like this. So, in reinforcement learning. And if you take like AlphaGo, AlphaZero, MuZero, whatnot, they have the ability to play chess, Go, StarCraft, and so many other things at a level that no human ever would be able to compete. Yeah. Right? Would you agree also that like AlphaZero and for the narrow task of just playing chess, it's still some kind of iterative reasoning happening there.
Probably, yeah.
But it doesn't really have a world model of GPT, so it doesn't really understand all the semantics of the world. It just understands the positions on a chessboard, for example.
Yeah, I mean, it has a very limited world in a sense, all the valid moves.
So now the question is, what happens if you combine the two? If you combine the power of the reasoning that you can see in AlphaGo or AlphaZero with the world model that GPT, or at least the GPT-3 or 4 potentially have, which doesn't have the reasoning ability, but potentially now if you add that reasoning ability to some kind of high-level abstraction or semantic understanding of the world and let that reasoning happening on that level, we will potentially have a combination of the best of both worlds, both the perception of the GPTs and the reasoning of AlphaZero. Would you agree?
Yeah. I really think that's and that comes back to kind of the tree search. Like you want to select the best path towards reaching some maybe intermediate goal. So I think that's probably really powerful. But I'm also a bit doubtful that we have solved it because I mean in all the games, even these. OpenAI hired, I think, from Meta, a researcher that has built these poker algorithms. And poker is a bit different since you don't know you don't know the opponent's state and stuff like that.
You don't have complete information.
Exactly. So, but I don't think they have fully solved it. That's my guess. I have no idea.
So.
But it would be very powerful if they could, but still probably not all that we need. I still think we need some kind of long-term storage, memory, whatever.
Now you speak in Jan LeCun terms, I would say. Okay, so if we take the question, is the Q star algorithm, which we know nothing about, we're just hearing people speaking about it, but would it potentially be adding the reasoning capability that has been lacking in GPTs, which makes it at least closer, perhaps not fully to the way, but potentially closer to the goal of AGI?
That's a good guess, I think, that they have come closer. But also, I think, so if you solve really hard math problems, what you show is that maybe you can utilize a general GPT model like GPT-4 that has this maybe good way of guessing hypothesis based on like the math papers that it has read, and then you have the scoring function. You can still always tell when you're right. So it's in math, right? Because you know if you have the correct answer. So I think we need a lot of innovations to do that in like the world. When are you correct in folding your laundry? Right. Kind of maybe when they're in the drawer. I don't know.
Have you read the JEPA paper, by the way?
I've tried to, but I haven't fully kind of digested it.
But you were saying stuff, missing the memories, storage and stuff, and that's basically what they are trying to say. That and Jan LeCun is very famous for saying that he thinks the autoregressive nature of large language models is not the path forward. No, and he's promoting these kind of energy-based models, and also.
That's confusing to me. I would love to like really be into the energy-based models, but I can't quite fully at this point understand what differentiates them.
I mean, okay, I shouldn't go into details here, but one way to think is simply that you want to, instead of predicting the next word, do some kind of inference in the land of semantics. If you have some kind of representation of the meaning of stuff, some kind of semantical topology in some sense, where you have some input, which is text or images, but needs to be encoded both from the input and the output. Instead of predicting directly the output, what you predict is the semantic next step.
Yeah, exactly. In the kind of, you're moving in the latent space, so to say,
So that's more getting closer to energy-based models. You're predicting latent space. It's like mu0, if you know, is moving, or even stability, that is predicting the next, what the image you want to have, not pixel by pixel, but in some kind of latent space. That's right? So by having the main type of reasoning happening in latent space, in the vector space, as Elon Musk called it, then potentially we have something that is closer to the human kind of thinking.
Yeah.
Right? And then he also says, these things with, perception is one, the configurator, which part of the brain that is looking at what kind of task is another. You have the working memory, which is lacking. You have some kind of action you have to take. Anyway.
So,
cool.
but coming back to the Q-star, I think one way to phrase it that someone did on Twitter, of course, was that maybe we're just trading compute for power, right? So it will take a lot of time to explore this. Probably if they have invented this, it's quite slow and you explore a lot of paths, right? But you might solve really hard math problems. So it's fine in that if you want to do research or invent new quantum physics or something, to spend a lot of compute on the search. But maybe in everyday usage like ChatGPT, you want it to be fast.
Hey, Henrik, finally here, stuck in traffic or something, I don't know. But I think potentially it could be the opposite, which is that if you actually do the reasoning in the latent space, it requires less compute than you have the reasoning done in the syntactic kind of world. You see what I mean? Or?
Yeah, for sure.
Yeah.
So, if you, but I almost think that's two different themes. I fully agree with you that you can do higher order reasoning if you're in the latent space. Yeah.
Mm-hmm. Welcome here, Henrik. How are you doing?
2.5 hours from Värmdö.
Jesus Christ. Oh yeah, sorry.
So you talk until he puts the microphone.
Okay, yeah. Now we were just speaking about very technical things about Q-star algorithms and are we getting closer to AGI or whatnot. But let's not go too philosophical. I think we went a bit too fast into the philosophical topics here of are we getting AGI or not. We can come back to that shortly. But we would love to hear more about the GPT SV3 project. Can you just speak a bit about how did it get started? What was the origin? And please describe. How did it happen?
Awesome. So it's also really good because we internally call it GPT-3 and then have the 3 as this lead speak. But it's really confusing a lot of people. No one really likes what we have gotten a lot of criticism for the name. But anyways, so
what is it? So the 3 doesn't have a meaning.
No, it's just an E and maybe some silly
so it's not a reference to GPT-3.
Well, it is a silly reference to GPT-3, but as an E as in Sweden. Yeah, it's probably
it's like a Gothenburg joke.
Yeah, exactly. so but I think the project has kind of humble beginnings, as in we have explored this, like we talked about earlier, via the RISE, explored language models for Sweden, in a sense, mainly with BERT models. But then the Wallenberg, Knut and Alice Wallenberg Stiftelse donated a really large supercomputer to Linköping University for research. And we got early in that. And then we saw our chance to, during the trial period, so maybe we can actually train a large model for once.
And for the tech nerds out there, can you just describe what is the Berzelius cluster?
Yeah, so it's the first, so they have actually built a bit upon it, but the first is 60 DGX nodes with 40 gigabyte A100 cards. And so in each node, it's eight A100 cards.
And could you translate that for me?
It's 480 A100s.
Yeah.
And what is an A100?
Yeah, it's one of the top, or kind of old these days, or at least a couple of years old, but a GPU.
It's a GPU, and what is a GPU?
You get the child. What is a GPU? What is a graphic card?
No, it's a graphical processing unit,
Yes. Cool. And so they had 60 GGX, each of them having 8 A100, 480 GPUs in one cluster with really nice InfiniBand kind of connection.
Yeah, exactly. That's a really good computer, basically.
It's like a supercomputer in Sweden, one of the biggest one that is specialized for AI compute. Right?
Well, is there anything coming close in Sweden as an AI first computer?
I don't think
GPU
so.
focus.
I think it's the second in Europe, actually.
Really?
I think Lime is certainly bigger, but we have a number of EU compute
Yeah,
clusters.
exactly. We have the zero HPC stuff. That's
a big one in Luxembourg. Is another one in Slovenia. It's
who knows? Maybe we have some secret computers in Sweden as well. It's the biggest known one.
But if we come into this classic HPC versus GPU, you know, are they all the same? A Cray computer, is that a GPU based computer or not? No. You know,
but even the Lime HPC cluster has a large number of GPUs in it. It's not all GPUs, but it's a large number. They AMD kind of GPUs, but still they are GPUs that can be used for AI.
And which one is Lime the big one in Europe? Where
it's the biggest one in Europe.
Where I know a couple of there are other jobs going on that people have done, even Swedish companies on that one as.
Yeah. But I think it was a really good move from the Wallenberg family and Stiftelse to actually support these resources. I think it really has made new AI possible in Sweden.
Yeah, I mean, Wallenberg has supported so many awesome initiatives, especially in AI, so that's truly great. Cool. Okay, so you had this big supercomputer, specialized for AI, and then what? What happened then?
Yeah, so we got the opportunity to use it early, and then we said let's try to build this initial prototype of.
Was this when you were at RISE or?
This was at RISE. So it was
like 2020.
It was just at the beginning of Corona. So
2021 or something.
Yeah, exactly. So we just ran this first test and kind of made a, to us, really large model. I think it might have been 1 billion or 3 billion maybe the first, and then we said like, okay, but maybe this is actually possible. Let's go with this and try to build a really performant big Swedish model. And then I think we were the first group to kind of being able to use all these GPUs in Sweden. So we got a lot of support from NVIDIA as well, because of course they want to show that their expensive toys can be used for good. Yeah.
Cool. You started with some. You started with some kind of model that you were going to train, like a 1 or 2 billion one. Was it a GPT-based?
Yeah. So an autoregressive language model. So what we have seen is that these seem to be. So we have this BERT family of models that you have to fine-tune often for the specific tasks, right? But GPT-3 kind of showed that you can build these more general models that you can solve like potentially any task with. So we thought this is probably the way to go, and then you can use this more general model to distill them or kind of use them as they are, or so on, to see if we can build this general resource for Sweden and the other Nordic countries. But then we also come to the fact that these models need a lot of data. So do we even have enough data in Sweden, and so on? We thought the answer might be no, at least to easily available data. So we added Norwegian and Danish into the model as well.
So you built this kind of, what was it called, the pile, Nordic pile?
Yeah, the Nordic pile, exactly. So we spent like four people full time, spent 6 months in just collecting and cleaning the data. So I think these projects are really kind of hard. So we of course believe that the value is really great. But it's also not entirely sure, so you have to spend a lot of resources in doing this, right? So it's a big bet.
Okay, so you were 4 people, you said. Was it all from RISE or some other people as well?
No, so at this point we had moved, so the first prototype was at RISE, and then we made the transition from RISE into AI Sweden, some of us. In collaboration with RISE, some colleagues stayed at RISE. So AI Sweden was the platform that kind of enabled us to focus fully on training a GPT model. And at RISE, we had all these different projects, which is really made sense there, but made it hard to spend the time needed to just train one model. So at AI Sweden, we managed to get the focus under Magnus Sahlgren to really focus on one thing. Yeah.
Awesome. So you focused 100% on building a big Nordic large language model based on GPT and so on.
Yeah, exactly that for a year, basically. So 6 months for like collecting data, cleaning, and approximately 6 more months for training. And I mean, the group was up to 10 people or 12 people, but like the actual full-time focus was more like 4 or 5.
What was your personal main focus? What did you?
So I was the whip, I think, or the technical lead. So I was nagging everyone to collect more data and to calling Berzelius and saying, it doesn't work, and so on. So kind of a technical lead, but this is both really cool and depressing at the same time, that the scale of these things are so massive and the scale of these projects. So it's cool that we could do it, pull it off in some sense, but it's also a bit depressing that we don't have the ecosystem to do it in Europe and Sweden fully in place. And I think it's also hard if you're doing a PhD, for example, you're supposed to publish individual contribution in the form of papers and so on, and that's not necessarily easy to do if you're like part of a bigger effort.
Yeah. If you're engineering based as well.
Yeah, exactly.
Were you trying to pursue a PhD as well?
No. I'm a dropout researcher, right? So I will probably never do a PhD.
Yeah. But it could be interesting here. Actually, simple and concrete question, but I think it's a little bit a question nice. Under the hood. Could you kind of elaborate a little bit like how you organize the project work when you build a large language model? So are you working sort of agile scrum, and did you have a backlog, or how is the work organized on more practical terms?
So I think we definitely had tickets, but as researchers, we're also bad at collaborating, right? So we kind of had this organized chaos. But you have some milestones, right? So anything that drives towards the milestone. One milestone is like collect this much data, then do this with the data, like deduplication, and then
so you had an overarching milestone plan, like epics or whatever you want.
But I would say we're very startup-y in the sense of not having this very fixed structure.
You didn't have clear sprints with stand-ups every day or retrospectives and whatnot.
No, okay. And then the next, is it a very, I mean, like if you highlighted there's like 4 core people, like more or less fully employed, and then there's people that supports in different ways. So could you elaborate what's the profile of the 4 core and what is the profile of the rest?
So actually the 4 was kind of the sum of all the 10 people's contributions. Okay. So I think since we had a distributed workforce across organizations, for example, at RISE, so someone might have really liked a certain web forum called Flashback, and then maybe his contribution was really focused on cleaning Flashback really well, right?
That's not easy.
That's not easy.
No, exactly.
There's nothing left.
No.
Yes, exactly.
Well, not removing. I mean, just cleaning the HTML into a nice JSON format. Yeah. We would never remove anything from Flashback.
No, okay. So
but is that true? I mean, speaking about the data cleaning part, did you actually remove some piece of content, so to speak?
So I think we made a decision quite early on to kind of not moderate this, as these are foundation. I mean, in the ideal world, we're building a resource, right? So if we decide how the resource is going to be used in the beginning, then we might come up with use cases later on that it isn't supported. So, for example, if you want to use the GPT-3 models for moderation, it's maybe a problem if we moderated the data beforehand. So,
but there's a lot of like gibberish kind of data out there,
there's a lot of.
I mean, it's not necessarily like a bad content or bad intention kind of content. It's simply it's noisy data in some way, and it's
exactly. But right? that was what the kind of demarcation we tried to do. So we want to have high quality human generated data. Okay. Whatever humans write is not up to us at this point to filter away. But if we so a lot of the data comes from something called Common Crawl, which is like a public scrape of the internet, and there you have a lot of porn ads, and they are very generic and like include lots of weird keywords, right? That's not very interesting data.
And if you were to have a lot of like hate speech or something that is potentially really...
So short intro break here. So Brazilius is actually 151 in the list of top 100 supercomputers, and that is in the world, of course. And there is quite a lot of those in Italy and France and Finland and etc. So
But where is Lumi here in the list?
Lumi is actually according to this is 5 petaflops Brazilius, and there is like several versions of Lumi. One is actually here somewhere. I just saw it. It was around 100. Lumi C is Finland. It's 6 petaflops.
But it must be other Lumis.
Yes, so I think this is not the original one because Lumi was in the top 10.
Yeah, it should be.
Yeah, so this is like we are not even on this list. So I retract from my statement that it was the second biggest or whatever. There it is, Lumi. So 380 petaflops.
The main Lumi setup is huge in that sense.
I mean,
but it's interesting now because
150 times bigger.
I mean, like you know how you do it, right? You always need to define the list you're in yourself, so you can make the criteria sharp enough so you can win, right? So Lumi is HP Cray computer. And I mean, like, so, and then the argument.
GPUs as well. It's not Cray computers.
No.
It's HP. They have some Cray, but it's mainly a lot of AMDs.
So the AMD part here, that's the GPU part for sure. So it's interesting, like you can in the HP world. I mean, like. Maybe it's just fun, but you know, what is AI focused 100% versus just a big boy computer? But I don't know if that's any relevant information.
But this is a great list. You should always basically invest in stocks in all these companies that are supplying to these supercomputers because they will need to change it.
Or they invested in the wrong type of compute. So.
All right, true. Then.
Yeah, but back to the story. So there are about 10 people. Could you elaborate a little bit about their competence spectra that the team needs to cover to do this work?
Yeah, so I think, a keen interest in machine learning is a good prerequisite, but I don't think necessarily that all of these 10 people need to be PhDs. So you need to, at this point, this is so much engineering work, so you want really good software engineers, right? So you want some people that can collect data in a structured way and kind of make a system for that, clean the data, deduplicate the data. And then you want the HPC person or persons that kind of can figure out how to... you can probably use a framework. There are a lot of frameworks, so you don't need to be really low level in the supercomputer. And
you use the Megatron, right?
Exactly. So we used a framework from NVIDIA, and that took care of all the nodes, the separate computers in the cluster talking to each other. So.
Because this is my point, right?
Yeah.
So you need people who knows machine learning, yes.
Yeah.
But you really need software engineering skills.
Yeah,
you need
definitely.
hardcore software engineering skills, and then you need actually quite operative system close topic. Maybe you don't need to go into the hardware, but you need to go into the software of the operating system, right?
Yeah,
and
like the cluster or
the clusters
computer,
and to configure and make the whole thing work. So it's not one type of engineer. I mean, like this becomes a teamwork very, very fast.
Yeah, exactly.
And I think this becomes extreme, but I think that's the bottom line.
It's cross-functional team,
cross-functional
right?
in any.
And engineering is always, I think, the main need, right? That you have to have. But perhaps also some business people or some project management people, or
yeah. Probably. I mean,
where is your forte as a technical lead? You know, where do you put yourself in? Sort of, if you were T-shaped, where is your sort of?
Yeah. So I think I'm kind of I can program, but I'm quite shitty at it. So I think I have like this really broad overview and kind of some also shitty product manager in a sense.
Yeah, but it becomes actually a super important role because you need to know enough to be dangerous in many things in order to technically lead it, right?
At least at this point, for this scale of the project, it was really good to have someone like knowing all the all the parts. And I think that also was really diving down into the different data sets that we wanted. So it's funny, this paradigm, if you're training large language models or if you're fine-tuning existing ones, like in your company, you can see it as kind of defining or programming interfaces, but with text. So you need to kind of have data that emulates the end user's needs, right? So if you want to have a chatbot, you need to have data in a chat format. If you want to have a programming thingy, you need to have like maybe tickets and their solutions. Or I mean, so we had to cover as broad range as possible of different use cases.
Perhaps it's time to, if we phrase the question like this, what would you say the main challenges was in hindsight, so to speak, of actually building GPT-SV, SWE,
yeah,
as
exactly.
we should call it? What were the main challenges, you would say, or if you look, backwards in time?
Just spending enough time on everything, getting the people together. So spending 6 months with data, getting to do that's definitely something that we...
So you didn't think about that ahead of time? It was something you realized afterwards that you had to spend
we
so
had
much time?
I think a flexible situation where we could extend also the data collection phase. So I think really collecting the data is the hardest part. It's 50% data collection and 50% training, surprise. But you have to also really be determined, right? So there is a lot of, I think in Sweden and in general, I mean, questions, should we really do this? Is it worth the effort? What is the outcome? Can they be used? And it's kind of like this promise with this technology is that we will build AGI, but building the foundation is really expensive, and it's only a promise that we will build AGI. So now that we have the foundation models, people have to like use them at their companies or at their
was that the goal, or what would you say the purpose for building GPT-SV was?
I would definitely say just to get it out there, to hopefully
to find
people
proper practical use for it?
Yeah, definitely. Just to get the artifact out, but also I think building competency within Sweden.
Yes.
And for us in our group, I hope that we can disseminate and that this can be replicated. I just think more people in Europe and Sweden should train models.
Yes, very much agree. Okay, so the main challenges, I'm trying to get some kind of understanding of that. One was simply that it takes some time to do data collection. That was perhaps underestimated to start with, at least. And then also doing the training, did you come up with any surprises? Was it anything that you didn't really expect when you started to train the model? Yeah,
I think actually the HPC system is not set up for large language model training as they are in Europe and in Sweden today. So you do like small jobs, but the large language model training, so you only are allowed to like use your allocation for 48 hours at a time. But for the language model training, you want to use it like 100 days at a time. So kind of like very technical setups with the HPC system.
What kind of HPC kind of setup? Do you use Slurm or something? Or?
Yeah, that is Slurm at Celius, and I think it's quite common. Yeah, but like OpenAI, they have their own like Kubernetes flavor or whatever. I think, but they also kind of know what they're doing and what like they want to build out the workload for inference and stuff like that. So.
Okay, so some challenges in simply making a large language model training work in a HPC setup, which it wasn't really set up to do to start with. And then during the training, was it anything like how do you select the model architecture, all the hybrid parameters and whatnot? Yeah,
exactly. That's also. But I really think that I will come back to your question, but I really think like the real challenge is just in Sweden, I think just collecting getting this thing organized and finding the funding for it, I think.
So the economics of it and the, let's say, recruitment, I guess, in some sense.
Yeah, exactly. And just having someone brave enough to bet on it. Hopefully again and again and again.
So it's a little bit like you need to sort it out in the total project challenges, and then you can go into the technical scope.
Exactly. But when you start to, also machine learning is or AI training at this scale is a bit weird. So when you increase the size of the models, they start to, like, I guess it might be compounding floating point errors or something like that. So they start to diverge, and it's like when we trained the model a year ago, then it's literally unknown. So the best bet was when you train a large model, if the loss goes up catastrophically, pause the training, remove a couple of batches, and then resume without any explanation of why.
Just to have people understand this properly, because they may not be understanding it. So this was like a multi-month kind of training process, right? Sure. And then you saw the loss curve. Normally it should be going down in a nice, very smooth way. And then suddenly you could see it coming up. And what happened then? Did you actually stop the training and then you went back some number of steps, batches, and changed some hybrid parameters? Or what did you do when you saw this kind of thing happening?
Yeah, exactly. So when you train these models, you really want them to continue learn all the time. And if they stop learning, you have a real problem. But for us, we really were lucky in that they stopped learning for a very short while, and then they went back down without any action. Without any action, but the appropriate action that we would have had to do was stop training, remove some random data, and then continue, which is really unsatisfactory.
Yeah, I saw some, Meta, they released like a log of
exactly.
Did you see that?
Yeah.
And they
for the llama training.
Yes. And they did a lot of stopping, tweaking, restarting, continuing, and it was very interactive or kind of.
So this is now we're getting into super large training where the training exercise takes months.
Yeah, exactly.
And then how do you get the training exercise to flow efficiently?
Yeah, exactly.
And then as soon as it doesn't do it, it's actually tweaking happening, and all the big boys, literally, this is part of the game. I mean, apparently, right?
Yeah.
Okay, so you didn't have that kind of experience that much?
No one. I mean, we definitely had to learn on the fly, right? Cowboy style.
But you didn't experience any really bad setbacks here? You had a fairly smooth ride, it seems like.
Well, I mean, so in terms of wasted computes, I think we had some setbacks. We trained a model. Luckily, it was one of the first trial models, but we managed to train it without any. All the documents that the model read was merged into one document, which is really, really bad for the model. So it doesn't know when to stop. Basically, it just rambles incoherently.
So this is an architectural.
No, it's a data thing, but in the end, so we trained a full model that we had to throw away. Stuff like that happened, definitely.
So just to go very quickly into some technical details here.
Yeah.
You have to put some kind of batch that it trains on.
Yeah.
Can you just elaborate a bit? What was the batch size? Can you see what was the context window size that you actually trained on? Just to give some idea, at least, of how it worked.
Yeah. So we did a very kind of vanilla choice with regards to architecture. So it's not exactly a word, but the model can read 2,048 tokens at a time, which is approximately 4 A4 pages. So 4
pages of text.
Yeah, exactly. And what?
Did you have some batch size? Or
yeah. So you have a really large batch size comparatively, 1,000 of data points.
So 1,000 of data
we have
points,
the exact
each of
numbers
them being
in the articles. So.
But then each of them being 4 A4 pages.
Yeah, exactly.
Text. Cool. And then you trained it, and what was the time for each step, you would say? For a single step, was that
That's a good question.
But is it minutes, seconds, hours?
No, it's probably seconds. But then we made most of the training on 20 nodes, so we didn't get to use the full of Berzelius because there were other people there as well. So when you have a lot of GPUs, right, then it's still. But we have a lot of data, so even though each step takes quite a short amount of time, it still has to run for months.
Cool. Now let's not go too nerdy here, even though I have a lot of other questions I like to hear.
But I think it's to paint the picture of how did this what what does these types of projects entail? I think it's super interesting and demystifies in many ways. So I think it's quite okay. So let's take another one. How does it work in practice when you work with Braceli? Are you many different research teams there at the same time? Are you competing? It's my mega flop. You know, like, can you have this window? Like, do you need to plan windows? How does that work?
Yeah, it's definitely a competition. So you have a kind of a ranking system. So but this is built in this software for managing these clusters. But the one with the most compute gets the highest ranking, right? So we were quite high in the ranking system because we needed so much compute for our large training runs.
But you keep the same machines, or do you get allocated these machines and they continue to use that, or do they actually switch out to different machines during the training?
No, during the training, like for one kind of allocation, you get to keep the same machines. But then as soon as you stop, you get new ones when you start again. Yeah.
So how does that work? You go to Braceli and you basically request, we want to train our model now. Is that one work? Is that you get an allocated set of machines, like GPUs on this?
This is actually interesting. So Berzelius is an academic resource, and they're not allowed to. You can't do any like commercial work on there, and you have to be affiliated with, I think, the Wallenberg WASP in some sense. But we also have in Europe, actually, I just talked to them before I came here, the Euro HPC, the European research clusters, but you can also use them as SMEs. So you can actually apply for compute as a company. And then you have to go through the application process and so on. So, but I think it's probably something.
But let's take your example now with Braceli. There's an application process to get into to train the model. So you needed to do that sort of paperwork first.
No, so we had we know a lot of actors and had an active collaboration with the WASP, Vara Media.
Yeah.
So basically, we were part of the systems that got to access the. Compute.
And then in more practical terms, how do you plan a training gig of this magnitude? How does that work?
Well,
because then you need to apply to, we need to, how many?
Exactly.
How
so
much
in this case, since it was kind of new for everyone, we got the allocated time on the supercomputer, but then it also didn't work. So we had to, because it was new and we don't know what we're doing and they don't know how to train large language models. So we just had to call them and say like, it's not starting for some reason. Yeah. And can we do this now? Yeah.
Did you SSH into the machines? And
you SSH. It's like in the cloud or something. You just SSH and press Q.
So you're not physically in there.
No. But then you press Q and you're like, nothing is happening.
Yeah. Exact times. All right. Yes.
It's time for AI News, brought to you by AIAW Podcast.
Yes, awesome. We have this kind of middle break to just speak about some exciting news articles happening, and then we'll continue the discussion about GPT-3. But before that, each of one can pick some kind of top news story that we want to speak about. Anyone that wants to go first? No?
I went first last time, so I don't want to go first this time.
All right, so then, because I always have a couple of those, so I will
shoot them off.
Right, so I found three interesting actually articles. The first one is actually that Amazon is launched Q. I hope it doesn't have anything to do with the gossip about Q Star, but launches Q, which is a business chatbot powered by generative artificial intelligence, which is basically helping the employees to streamline day-to-day communication and basically we do different tasks like generating blog posts and etc. So obviously they don't like to use different type of or others. Chat GPTs, let's call
them like that. Perhaps it's a James Bond Q kind of thing.
Yes, it might be, but in any case, they are going into the race, and you can see that the giants are actually fighting for more of these chatbots now coming in. The second thing, it was a very interesting because of my chemistry background, is that Google DeepMind researchers have discovered 2.2 million new crystal structures. All right, it took us. I don't know how many years to come to what we know today, and just basically by utilizing this AI tool from Google DeepMind called GNOME, they have actually found 2.2 million crystals, and 381 of those crystals right now are going to be available for scientists, so they can actually start developing products and services on this. And this is huge. We are coming to a point where basically AI can help us actually create more sustainable and more better performing actually materials.
AI is empowering researchers,
yes,
even in chemistry.
Yes, imagine what Marie Curie would do to have an AI tool like this and not die by radiation poisoning. And the second thing, the last one is actually a very interesting news, which is actually the State of European Tech report came out. This is basically a report that is looking at Europe, especially...
It's from Europe as well, right?
Yes,
because
exactly.
I think it's a bit biased when I say
this. It is a little bit biased, but basically it's a report that is looking at the European market, especially the startup, the tech industry, and etc. And one part of that is very interesting, which is focusing on AI. And the interesting part is that right now Europe is actually outgrowing the number of practitioners working with AI for a bit, so it's increasing very much. So right now the ratio is 108,000 AI professionals working in Europe in comparison to 87,000 from US. If you read the report...
Is it relative to the number of people, the population?
No, it's actually how many people are working with that. So it's not a ratio.
So in Europe, is it like 350 million people or something? And in US, it's like 300?
Yeah, pretty much.
So it's not really a fair comparison then?
Yeah. Is it? Does it matter?
It's a bigger market than...
No, but what is called, there is another part of this which is super exciting as well, that Europe is becoming a hotbed actually for AI startups and research projects. And also if you go up, you can see that more actually people are moving to Europe than actually AI research going to United States. So we have an inflow now of brain instead of drain brain that we had before. Here
That's
it is.
really positive.
Yes.
That's true.
So global tech employee arrivals and 2 in departure from Europe. So as you can see here, it's saying Europe is winning over international talent, and people are moving from US to work in Europe tech more than European talent moving to...
I wonder if they include US tech companies as European.
As you said, this might be very biased, but it doesn't matter. It's a super positive news. Okay, so don't ruin it. Move on to this one. That was all for me.
Yeah, awesome. Okay, should I go next? And perhaps it will be a bit boring topic because we started speaking about regulation a bit before, but I think we had an interesting development happening in Europe when it comes to regulation of AI. And France, Germany, and Italy actually joined forces now speaking about how to regulate foundational models. And if you look more into the AI Act and their latest kind of definition of what kind of regulation they should have, they have a specific regulation for foundational models per se, independent of what they're used for. So they're regulating the tech. And now the reason that France, Germany, and Italy went together may be a bit biased as well, because at least both France and Germany have their own large language models, the Mistral from France and Aleph Alpha from Germany. And they realize, if they are punishing these kind of super exciting new startups and initiatives in France and Germany, it will be problematic for them. But they said something that we have said, Henrik and me, time and time again.
We've been on this for so long.
And that is, we need to, and this is quoting the German digital minister, we need to regulate the applications and not the technology. I mean, it's so weird that we said this for so long. And finally, we have some people that
and some people are saying it, and it comes out of many different reports, which is over and over saying the same thing. So,
and all the people we had here on the podcast saying also the same thing so many times.
But still, in the AI Act that is the formal one, it doesn't say that way.
Yes,
unfortunately.
But it's kind of obvious as well. I mean, if you want to have this kind of rules or regulation for foundational models, not the application, you don't know what they are going to be used for. You just say, I'm going to train a new GPT-3 model. And now suddenly AI Sweden is going to have to regulate all these kind of things in advance before they know what it's actually going to be used for. how can they? I mean,
exactly.
it's impossible.
It's so stupid because even in the GDPR laws today, if you have done any point working with data privacy officers, the first thing they want, I've had this problem because how can we make the platform GDPR compliant? And in reality, you can't because you need to have the use case. The only way when they can apply the law is what is the application of the GDPR data.
How do you define high risk without having that?
What we have been taught in how we do data privacy and everything like this is that basically the law states very, very quickly, you need to do a LIA in relation to a specific use of that data. And here now, why are we departing from that? I don't get it. I really don't get it. So because you can learn from GDPR, you can learn, we have been taught to work in a certain way, and now you're flipping the whole game on this. It's a completely, it's not making any sense.
It was a different section of European Union,
Yeah, no.
Departments do not collaborate.
Department A was working on that, and Department Y is working on this, and they don't like each other.
Exactly, that is the thing.
No, I'm really glad that people are moving in this direction, but it will be super interesting to see what happens to the AI Act now when the at least three of the top superpowers in the EU are going against the EU Commission here, or the Parliament. I think this is driving this the most. How can they proceed when France, Germany, and Italy are saying this is not something we support? How can they even continue? I wonder, what will happen.
No, but I found this news a couple of months ago, quite detailed views from a US perspective, how they basically think
By the way, this news was from this week.
Yeah, this is from this week, but I'm just iterating that I actually did a very provocative LinkedIn statement in the lines of this, like what will happen now when basically we get to a point where you can say that this is anti-small business and stuff like that, and you get to a point where a country needs to basically say no, I simply don't agree with these regulations. I don't agree with how that plays out. We get to a point where companies or organizations, for different reasons, this is not feasible to be part of. So it's a very high stakes game in the making. When three countries now, if we are on a collision course or something that might be one of the most important resources in the world,
and they should finish the AI Act this year, before end of year. What do you think?
No, I'm completely with you. I really think, but maybe it's a practitioner's view. As a practitioner, you're really it's very evident what should and what shouldn't be regulated. But maybe the EU Commission or whoever isn't. They aren't.
But there's been so many good experts part of this game as well. So I don't know. It's really tricky.
But
tricky.
I'm completely with you.
But so regulation for sure, right?
Yeah.
It's how we do it, and not only the regulation itself, but the ecosystem around the regulation. So you get support and guidance, and lawmaking bodies to uphold, the regulation. So it's like the Biden, it's not only about the regulation; it's the whole package.
Yeah. But
I think we should standardize technology and regulate usage. That is.
All right, let's leave it. That's enough.
Yeah. Okay.
Do you have any news?
Yeah, I have. There has been 2 new Chinese open source models. So one is called Qwen, and one other is called DeepSeek. You can find them both on Hugging Face, and I think it's this really interesting times when China is releasing the best English open source models. Should we use them? I don't know.
That's interesting.
That's super interesting.
And I don't know their stance on certain issues.
Is it from Alibaba, Tencent, Baidu, or something?
I don't know yet, but it's from Chinese companies. Qwen with a W, I think. Let me see. You can do
DeepSeek.
Yeah, exactly. So it's 2 completely different. So you should probably take one at a time. And it's QWEN.
2W, yeah.
Yeah, and then you can write Hugging Face. something afterwards. But yeah, so that's my just an observation that China is really going open source strong, and again, I don't know what do we know what these models contain? How were they done?
It's coming from Alibaba actually.
Yeah,
so it's
is,
one of the 3 top ones for sure.
Yeah, exactly.
It's nice they have an organizational card. Interesting.
And it's multimodal with audio and whatnot.
But they had a Chinese model called Wudao 2.0. I think it's like almost 2 years ago or something. It was like 10 times bigger than GPT-3. It was 1.7 trillion parameters in it. And they have been doing this for quite some time, and right? Then the performance on it, we don't know, and can you trust what they're saying? That's kind of hard, right?
No, exactly. These models are top of the benchmarks, and hopefully they didn't train on like the benchmarks, right? But on the other hand, if these Q-stars news are out there, and maybe they know what that is as well. Who knows?
Who knows?
Yeah.
Did they publish how the model looked like? Was it a GPT kind of style model?
Yeah. I think it's very open. They're just like have a really good data set that they're training on, and
it was good for English as well, right?
Yeah, it's supposedly the DeepSeek is really good for English.
It would be fun to hear what they think about the Himmelska Fridens Torg kind of
thing,
right?
If you dare to ask it.
Yeah. Okay, we shouldn't go there. Super interesting, and we can see that there are 2 main superpowers in the world doing this. It's tech giants of the US and the tech giants of China. They are far ahead of everyone else. But we have at least Mistral and Alpha, and they're trying to.
And we have the European Parliament as well. Don't forget about that one. That is a superpower regulation.
Okay.
Yeah, all right. Okay. Yeah. So cool. I made an effort to try to find news outside the LLM world.
Really?
Yeah. So Tesla, they released. They came up with release 12 of full self-driving, and they released
version 12.
Version 12 FSD version 12 came out to employees this week. So we're talking about update 2023-3810 for the nerdy ones, and this is a fairly big deal.
Yes, very big.
Because this release is actually when if you know the background, how the self-driving car in Tesla worked, they had a large portion which was still rule-based for a long time. And then they started to switching out to basically do everything deep learning. So basically, we are training how the car acts purely on video, on video experience. And then they put that in beta, and now they are putting this out as they are basically taking away this is the release when now the rule base is almost down to 0 or very, very small. And what happens now is like it actually becomes way cheaper for them as a way to sort of move forward now, because you have a very simple rule base, and then it's all about the model, and the model you train big, and then you take the next update and drive it to the car. So I think this is a fairly big deal.
I think it's interesting also when speaking about AGI that we have, before they had, of course, deep neural networks for perception purposes, but as Tesla described it, they have 3 main parts. It's the perception, it's the planning, the reasoning, and control. Yeah. And these are really hard things. Perception has always been deep learning, machine learning based.
This is a camera, it sees what it is, it defines it's a dog, it's a cat, it's a stop sign. That perception part of AI.
And that's basically what GPT is today. It's just perception from going from text to some kind of vector space. Yeah. And then, it doesn't do that much. It's some kind of reasoning there, but it's very low level. It's not kind of iterative reasoning as we spoke of before. But now, before they had version 12, did manually rule encoding. So they have manual, people writing rules. This is a traffic sign. It's red, then stop, basically. And now they removed that, but they also removed the control part. So control basically means should you accelerate, should you brake, should you turn left or right. And that part was also rule-based before. Yeah. And I think, even when you say Q-star and which is potentially the reasoning part, the control part, the planning part that Tesla has. And you have with Q-star the ability to combine the perception of the GPT model with some kind of Q-star planning, they still don't have the control part. The control part would be also, what action to take. So control can be, in GPT sense, do a search on Bing or Google search, or it can be write an email, or it can be, if you connect it to some kind of robot, some kind of physical artifact, it can be go to the kitchen and pick up the plate. And that is really hard. The control part is very few companies that even work with.
And now we're putting that in a release that is now into car.
But even like Boston Dynamics, they have these kind of robots that are really cool. They can jump around, they can dance, they can do so many things, but they are not using deep learning for a control aspect.
Oh. There's really quite substantial part of rule-based in many of our systems. We talk about our drones. I mean, like even if you DJ like drones, right? Or they can fly. They're all this. A lot of the compute is still rule-based, right? Yes. But here now, Tesla is actually now the rule-based part becomes very, very small with FSD release. And the interesting point is, of course, they've done it for a while, but now it's open employees, and now it's the release that is going to go out in the cars. I think
it's so big. People don't realize how big this is because in version 12 they don't have to label stuff. They don't have to say this is a lane, this is a traffic sign, this is a person, this is a car. It simply learns it. But
this also kind of comes back to something we talked about earlier. In a sense, it's not hand labeled, but most likely, I mean, all the Teslas have cameras, right? And they collect data. But what they did is they designed the behavior by selecting the data, right? As we talked about in LLM. So in a sense, you still kind of you just don't have to touch like the really low details as you do with the rule base, but you still have to like, oh shit, it's really bad at intersections. Let's add some more nice intersection data, and that's how you should.
This is how you design it.
This is how you design kind of LLMs as well. Okay, it's really bad at browsing. Let's add some more browsing examples.
But I think you can phrase it. I would phrase it differently.
Though. Yeah.
Okay, so
I'm happy for discussions.
It's a good angle. It's a good angle, though.
The problem with the rule-based approach is it's easy to handle the most common use cases. Yeah. When you're just driving on the highway, no problem, everything works. But when the extreme edge cases happen, some elephant walks across the street, what should you do? What's an elephant? You've never seen it. That is the really hard thing, to add manually encoded rules for all the kind of weird, strange, never happening kind of edge cases. But if you have a machine learning approach to it, then it can handle edge cases. I think this is really the big point. And I mean, it's the same for it's a big point.
But it's a big point. And it's also, if when you start marrying this out, it's a little bit like we have the LLMs, and like the whole Q-star, all that thing. It's about this planning piece. Yes. It's about this control piece that is lacking.
That's why I think Tesla is so much further ahead in actually coming to some AGI, because they connected perception with reasoning and planning and control.
So there is a rhetorical question. Who will win? The person who has figured this part out and gets better at LLMs, or who has the most Tesla AI supremacy?
Elon Musk has LLMs now also with growth.
And the robots.
But if you read
the robots, and Tesla bots.
It's right it's in his biography. The argument like, okay, they have LLMs, we have this part. What's going to be easier for us to pick up this part, or for them to pick up our part? Let's go.
Yeah.
So I think people don't understand how difficult this real world planning is.
Yes. The control part especially is super hard. And planning is hard as well.
No, I agree, but this also, I mean, we have some auto companies in Sweden, and I think so the planning is super hard, but also getting the data. Like all the
perception part is not easy either.
No, but we're not collecting enough data in Europe. Like all the trucks, Scania trucks and whatever, they should record everything.
It's a brilliant move that Elon set themselves up for this success. From the beginning, right? Yes,
they planned it from the beginning.
If you're a fanboy, I mean, there's moves he's made. First of all, he made the whole thing, but started recording. Then he made a very strong vertical integration from the sensor to the dojo, very, very early. Very, very early vertical integration that you can't really get to if you don't own the value chain, so to speak. So some very fancy moves here. That's not easy copy.
It's weird times we're living in. It's happening so many things now, so it's quite crazy.
I was watching this YouTube video about from investors speculating. This is pure speculation. How Tesla is going to look like in 2020, 30? Where their revenue stream is going to come? And there are two people there and discussing, and one is asking him like, "What do you think?" And then they're discussing about the cars, and then the other guy just basically completely annihilates himself like, Tesla is going to be making most of the money from AI robots. Yeah. It's going to be the number one AI robot company by 2030. The second one is going to be battery, and then basically the car is just going to be a proprietary thing that you do, but it's not something that they will develop more. Yeah. And if you look at it when they are going, it makes sense, right? So he's putting himself out very smartly. Let's see after this FU statement if this is going to be something that he can survive. But
anyway,
let's go.
Many crazy things, but it's actually a milestone that happened this week that is quite deep for the planning and control part in AI.
Yeah, let's see if Elon Musk can keep it together given all the tweets he's.
Yeah. do we mention more about Q-Star's news, or there's been so much gossip, right? Yeah. And I was quite happy we were on the gossip at the front of the gossip, yes. But do we need to mention some more about the Q-Star gossip?
I think we've spoken.
Then we move on.
Yeah. Should we go back to GPT-3 here, and perhaps if you can, Ariel. Can you give some examples of some potential use cases that GPT-3 could be used for?
Yeah, absolutely. So we have an actual use case that I think is really great. So Region Halland, which is a caregiver in Sweden, they have tried to take a very specific part of journaler.
Journals?
Yeah,
medical journals.
Medical journals, a very specific part, and summarize it. And have had some success with GPT-3, and that's really good. If you can do that in a safe and reliable way, it will save doctors time, quite a lot of time in the care.
So you mean when a new doctor comes in, they have a new patient, they can have a summarization of
but it's not any summarization. It's like a very specific part. So it's not a generic thing. It's called the epicris, and so it's a good thing for automation. And you can do that, and it has certain requirements. You can check that it's kind of fulfills those requirements. But then instead of the doctor actually writing it, they can just write out the notes, and then you can get the summary automatically. But in the grand scheme of things, that will save a lot of time. So I think these small implementations so in this case it would be a summarization thing, can really save money. I think
I usually love to say that AI empowers people, and in this way it really empowers medical doctors to more quickly understand the journals and the history of the patient in some way. Yeah,
exactly. And I think GPT-3, I mean, it's not as good as GPT-4. That's it's a smaller model. It's older. It's there's a lot of reasons why it's not.
So have you done a comparison for this specific task to GPT-4?
No, but that's the thing. So you can't you can't use it there because you have to have it on-prem, on-site, fine-tune it, and it's sensitive data and so on. So it's not live, but you wouldn't be able to use it GPT-4 in that case. So,
but maybe this is part of more practically understanding how can we use, or what is the operating model, technical model, or business model to use now what you have done, because how does it work? I mean, Halland, are they now doing something that goes into Berzelii and how does concretely they have now done a system of this? So what concretely have they done?
I'm
how
not
does it work?
an expert on them, but what I know about them is that they have bought some GPUs, so they have in their internal IT system, they have GPUs, a DGX machine, which is 8A100, and then they can run these models locally within their safe IT system.
So you need a lot of stuff to train the model.
Yeah.
But then what can I then take that model that is now the latest model, and then can I then use that at home? How does it work?
Yeah, exactly. So you can download it from Hugging Face, for example, from a web page, and you can use it. You can even use it on your laptop. It's not the ideal solution.
But I think we need to be super clear here and super simple here, because I think this is a confusion, right? You need all these GPUs to train the model.
Yeah, exactly.
And then when the model is trained and works, what have you done? You have put it on Hugging Face.
Yeah. So
and what is Hugging Face?
So Hugging Face is a platform for distributing open source LLMs and other machine learning.
It's now an open source LLM for anyone to download for free.
For free.
At Hugging Face.
Yeah, exactly.
So you go down and you go to Hugging Face and you search
for AI Sweden, I think, in this case,
yeah.
or GPT SWE3.
And then you download this model, and what can you do?
And then you have to know a bit of programming, and you can use the Hugging Face transformer framework in Python, and then you can actually run the model and kind of make it autocomplete text for you. And
is it available so you can run it in Hugging Face as
one of the smaller models, but for it's not ideal at this point. The running.
But compared to, I mean, there are other open source models as well, like Mistral or whatnot.
Exactly.
Have you compared or seen the performance of GPT?
Yeah, so those models are definitely better on English. And the thing is that in Sweden and in the other Nordic countries, we don't really have like standardized benchmarks. So it's not entirely easy to compare the models. But I would guess that some of the other open source models are better at completing tasks. So I think the GPT-3 models are probably the largest, the 40 billion model is probably the best model at writing coherent Swedish that looks good in a surface form. But maybe the English models are actually better at doing what you ask them to do.
No, but
so here we have some nuances, right? But then
have you done some kind of more scientific evaluation of it to see if it actually is better?
I mean, we have looked at Perplexity, but this comes down to we don't have the benchmarks, so it's really
in Swedish. You mean?
In Swedish, yeah.
But humor me. So I kind of understand it, but not the full way. So we have a model now, and we can use it as a GPT model.
Yeah.
So you can, I guess, prompted things.
Yeah, exactly. You can have your and there are all of this. So even as a researcher in the forefront, I feel like an old person, not catching up in the time. So there are all of these open source frameworks. It's like called LM Studio, I think, and Ulama, and these are open source frameworks where you basically can run your own. So this is not for companies. This is more for the enthusiastic tinkerer. But you can run your own large language models on your laptop, preferably a MacBook, and then you can just.
What?
Yeah, it's always better on the
preferably on the Linux.
Yeah, exactly. But they have these new processors. I think that's that. Yeah.
But okay. So humor me. So then you take this large language model, and what do you need to do now to do a use case like Halland? Like do you apply that with what is the next step here?
Yeah. So if you're a company, you should probably either buy a GPU, like some graphics cards from NVIDIA, or you can just spin them up in the cloud. And then you need to program a bit, and you can ask it to put labels on. I mean, you can, just as with ChatGPT or with the GPT-4, you can write a prompt in text. So you can ask it, you can paste in a text, like this is an email, and you can ask it to give the type of email. Is it a complaint or is it something else?
So if I go very concrete to the Halland case, more or less, so they have some sort of unstructured journal notes.
Yeah.
And then you put that into the the prompt.
Yeah, exactly.
As, it's enough tokens, blah blah blah, and then it's supposed to summarize it in a certain format.
Yeah, exactly. So in their specific case, they have also fine-tuned the model. So they have created.
Really?
Yeah.
What do you mean with fine-tuning then?
So you can when you have. So we have done this really generic model, and it's supposedly a little bit good at anything, right? Mm-hmm. But if you know that you will use the model for a very specific case, you might as well. And then we'll come back to this. Data thing, you might as well mock up the interactions. So in this case, you want to have the journal and the summary, right? So you want to show the model a couple of hundred or thousands extra data points that is like the specific interaction type.
So the continued pre-training?
Yeah, it's continued, but called fine-tuning, but it's the same.
But it's fine-tuning.
Self-supervised, it's not supervised.
No, exactly.
The fine-tuning, is that done on the larger model, or is it done in a subset, in a fork, so to speak?
So nowadays we have really efficient ways of doing fine-tuning. It's called LoRa or even Q-LoRa. So you don't have to spend as much compute doing the fine-tuning, but even if you're a mid-sized company and have a couple of GPUs, you can do full fine-tuning or this LoRa thing. So there
a stupid question.
No stupid questions.
The fine-tuning is done now.
Yeah.
Is that going back to the benefit of the whole model?
No,
or is it fine-tuning locally right here and now?
Yeah, it's in your place. Of course, since these are open source model, you could also put out the new fine-tuned model and share it with the world. But if you don't want to, you don't have to.
I'm asking stupid questions to sort of sort out the nuances here. That I think is quite difficult.
Yeah.
Awesome. So they can help with summarization of medical journals, and they also fine-tune, which I think is impressive, in a self-supervised way on the actual medical text, so it does understand medical language, I guess, in a better sense.
Exactly.
Awesome. That's a great example. Anything else that you can mention?
No, but I think my pet peeve with all of this is that. So I'll go a bit. I don't know if it's sci-fi, but talk about the future. So if you think about ChatGPT and you add audio and you add vision, so you add these multimodal things, what we will really end up having in the end, I think, is some kind of agents, not like the self-driving cars, but in your computer. So.
With control as well.
Yeah, with control, definitely. But today we have a couple of companies doing this. It's Google, OpenAI, Microsoft. So if we will have, and I think these agents, they will become like digital employees. So all companies will have like these digital employees and will pay money for them. So to me, the question is, who will we pay the money to? So I really think we should do this in Europe and in Sweden and everywhere. We need to do this because otherwise we will give all these. It's like the cloud. So we have the big cloud providers and they are basically taking a tax on IT. So we will have this situation again, maybe.
If I could just follow up with a small technical question, and this is, you have chosen in GPT suite to go Nordic with Swedish, Norwegian, Danish, and Icelandic, etc. What do you think about going more multilingual, say taking like 30 or even 100 languages or 1,000 that Meta is doing? Do you think that approach is beneficial in some way, or do you think it's still good to target the Nordic languages specifically?
I think if you have the scale like Google, it's beneficial.
To go really broad.
To go really broad with the 1,000. So Google has this Palm model that has been out for a while, which is 500 plus billion parameters. And they have seen internally, and they've written some reports about it, that over a certain scale, you can have like a majority language like English, and then you just add a sprinkle of Swedish or Swahili or whatever, and it kind of transfers the learning. So, but that only happens above 200 billion parameters or something. So in our case, if we will train smaller models or not have the compute, we should probably maybe limit ourselves. But this is also, no one really knows, right? So this is open question.
Do you have a view on that, Anders? Do you have a strategy? Yeah. Do you have a technical
I still remember
intuition on this? Do you have an intuition?
I still remember the old days of XLMR and these kind of things from Meta in 2020 or something, and they went really multilingual, and they said, this thing. One benefit, of course, in having 100 languages is that you have a single model for all. It's very practical, but there is another one. And that is, it seems to find this kind of generalization across languages. That means
transfer
that
learning.
If you actually add the other languages, it becomes better at all languages because it can translate and generalize across languages. So there is some extra benefit in actually going broad potentially.
But it has but of course it comes with the cost. It comes with the size, I guess.
No, maybe not.
No, but I really think it's open, and but Google claims then that only works for really large models. But I'm Not entirely.
Because
exactly.
the intuition here is that
if you add the reasoning part potentially, we can potentially decrease the size of the model significantly and still have the same. Right?
Yeah, sure.
Yeah, because the philosophical question, does it become better overall by adding more languages? Even the English becomes better because it has a deeper understanding of
interesting
language.
Example of they never added some kind of language from Bangladesh or
I saw
something,
this.
and it in some weird way it was able to understand this kind of strange language.
It reversed
even though
engineered
it never seen that language in the training data, right?
But we kind of saw something, I don't know if it's exactly similar, but even with word embeddings, that kind of the space of all the words, kind of, you could align them, and there is some similar structure in languages and so on. So, yeah.
I mean, I guess it's kind of similar to the initial kind of discussion we had, where we said, there is one type of reasoning happening in syntactic land, for the grammatical kind of logic or rules that we have, but there's another type of reasoning happening in the semantic topology, in the land of semantics, and that is general for all of them. So if you simply can do the encoding into this kind of land of semantics in the vector space or latent space of that, then you can really start to generalize all the data independently of the language you're using, right?
But I mean, I agree, but then also then we come to so there is this blue model, which is a collaboration between a lot of languages, it's a research model from a collaboration between a lot of researchers, then they chose to add a lot of languages. But the blue model is really quite bad. And that's because this minority language has really bad data. So you have this practical issue all of a sudden. So maybe the model would have been better if not all the Swahili data was spam. Or something. I mean, so you run into all of these weird issues.
Cool. What do you think about the future then for GPT-SWE? If you take the next thing, if you potentially continue the project, would you go? Yeah. What do you think potentially the next good step could be?
So I mean, we had some really clear learnings already from. So if we would have done the exact same thing that we did, we should have trained the models for longer. But that wasn't. So a year ago, when we stopped training them, this was not common knowledge. Today it is. Yeah. So okay, but
it started 3 years ago.
Yeah, exactly. So there is a lot of learnings out there. But going forward, I think we want to build AGI. So we want to. It's my goal at least. Okay. Yeah. But
what is the what is the next step goal? What is the objective and key results for this work for next year?
No. So I'm joking when I'm saying AGI. Yeah, but I think the developments in the field is that we want to make more general agents, like we mentioned. So we want to add the vision and the audio, if possible, and maybe actions, web browsing, tool use, and so on.
But what do you think about, to train these kind of foundational models, if you call it that, or frontier models, as they call it in Bletchley Park and executive order things, is there a chance for a small country like Sweden and then potentially together with Nordic countries to still compete with the big tech giants? What do you think?
It's a really good question. I don't know. I think naively, yes. But on the other hand, if you look to the GPT-4 technical paper, they had a whole team just for long context. That means increasing the number of documents that the model can read. So of course, we're not going to have a whole team for each separate issue. But on the other hand, the learnings. So I think yes.
Let's take a couple of angles on this. I've been following closely the developments in Norway. They put. It's been in the parliament quite recently. A lot of movement. Are you aware of this? I mean, so they talked about they're gonna put a clear billion as grants, and there's been an actually quite detailed AI. White paper report,
strategy and something.
Strategy, a little bit more than a strategy, and it's from one of the parties that sort of highlights a clear vision, and it's in relation then to a clear budget. So it's $1 billion Norwegian kroner, and there's a clear strategy how to spend that money. And here, of course, they talk about one of the aspects is that, we need a Norwegian, or they actually say we need a Nordic language model in order to also preserve the cultural values of the Nordics. So then, of course, should we do one of them each in each country, or should we try to find a way to collaborate on this?
It's a very leading question.
How far are you into the conversations before they start building their own fucking model the same way?
But I think, of course, I think we...
because you had to do the other languages because we didn't have enough data.
No, but I also think it's, it's planting the flag and inviting for collaborations. But I don't think we have a monopoly on building large language models. And I really think it should be commoditized in some sense, at least.
I'm just saying.
But I agree. I think they should give all their data to us, and we should collaborate, of course.
No. You should give all the data to them. Give them
no. We're the first, right? But but on the other hand, I really think it's important that everyone can do it. Like, it's not just because we have done something. I'm sure we're.
But how to really? My longest rant is like how to think about this now, because you clearly needed to use the other countries' data. It made sense even from a size perspective. And then we have Silo. They've come quite a bit with their reindeer. What is it called?
Exactly.
The Finnish word for reindeer. I can't remember. The model, They've done a quite extensive work now.
Yeah.
So...
No, but I'm super positive. I honestly think it's a good investment for people to replicate the work. I think that's the only way. By doing, we also know where the limits are. We know how to innovate.
The learnings you get from actually doing it, that's worth a lot, right? I think that's a clear win. But if you were to extrapolate like 5 years ahead, we can see some kind of really large foundational models happening, and very few players in the world could be able to train them, right?
But we had Volvo, we had Ericsson, so I'm not entirely sure where to place foundation models. So I really like talking about this, but at some point in Sweden we decided to start Sveriges Radio and Swedish Television, and we also started what eventually became Vattenfall, like the Swedish electric grid, right? So that's common infrastructure. Could AI in some sense be regarded as infrastructure? Maybe, I don't know. But it's also could be something else. But then we have like Ericsson and Volvo. And I don't know how people will make money out of this, but it wasn't like after the T4 came, everyone was like, nah, let's not build another car company. Yeah. That's not how it works, right?
I like it. Good attitude, I think. And even Spotify, as well. They had Google tried to do music. Apple, spent billions and billions of dollars trying to make a music service, and they failed and again. Amazon tried, they failed, and Spotify prevailed. And you can survive as a small startup as well, even against the big tech giants. So we should continue doing that, I guess. But the difference here is these are huge investments in building these kind of foundational models.
It is.
But I think it boils down to now, okay, what do we really need in order to put Sweden ahead? And what should we focus on? And we have the Poro model, Poro and Silogen. Well, that's a completely commercial alternative, right?
Yeah.
And then we have the Norwegian parliament, or parties saying that we need a Norwegian model. What does that mean? Do we team up? And then we have SWE in Sweden, which are all great initiatives. But it's also about how do we maximize the investment to make Sweden relevant and great. And I think collaboration is part of this game too. Otherwise, our money will not last anywhere.
Yeah, but I completely agree. But then there's always politics, right? So someone might not want to. This is not a jab at anyone, but people might not always be incentivized to collaborate either, because of internal politics or sovereignty perspectives. But then we also have the question will large language models or will ChatGPT affect our culture? So this is also I don't know, but the answer might be yes. So then it is also a matter of cultural export or cultural keeping some kind of integrity. Should we have vilse i pannkakan as some kind of foundation in this model, right? Or something that should we take really a lot of care in curating like this. So it's
but
one
this
thing.
Is the
like
argument by both the Poro model and from the Norwegian Parliament. This is the main. This is the main point
to me
keep this
open questions. I think, but. So if you
those values we want to protect.
Yeah, but if you take the Google model and you say, okay, but it will generalize. So you have like hundreds trillions English tokens, and then you add a sprinkle of Swedish, and then you say it knows Swedish. But okay, so it knows how to make these logical arguments in Swedish. But does it really know Vildsvinspannkakan, and does it matter? I don't know. What do you think?
That's a good question, actually.
Yeah.
Can we just ask a more technical question?
Yeah, sure.
You know, if you think about the next steps for GPT-3, and then if you believe the rumors about GPT-4, it's kind of mixture of expert kind of approach. Do you, for one, believe that is how GPT-4 is built, or do you think potentially that could be the next step for GPT-3?
It's a really good question, but. I definitely think that might be how GPT works, and for us, I think it's will we build a large model to kind of motivate going there? Maybe not.
Okay, interesting. The time is flying away, and I'm thinking about moving a bit to more philosophical questions. And if we take one, I mean, think about in general about AI development in Sweden and. How we really, if we wanted to try to promote, the beneficial use of, AI in Sweden, and perhaps also if you think AI Sweden specifically, what do you think the best way forward would be to ensure that we actually in Sweden can have the best possible beneficial use of AI? Do you have any thoughts about that? It's a hard question, I know, but
I really think it's on both maybe engineering or research side and on a very concrete daily life side. I think it's just engaging with the technology, right? So if you're
start working with it and then try it and experiment.
Yeah, exactly. So if you're a salesperson at a company and you haven't done anything AI, well, try ChatGPT, see if it can help you write an email or something. I really think as a general statement, we should just use it. It's like typewriter or the personal computer or something. It's probably a tool for efficiency. But
if we take the role of AI Sweden, do you think they can help that in some way to make this happen?
Yeah, I think so far AI Sweden is a networking place, and we provide some models at this point as well. So we are a national center, so we're kind of a project at Lindholmen Science Park. So in that sense, we're a very special organization. So maybe there is a future for us or for other state initiatives or even a governmental agency to work with AI. I think it's very open as long as we engage with it. And I also think that's something in the education system and then the higher education like PhD. We have to kind of face what it means to do AI. It's big collaborative projects. Our system is not super efficiently set up for that today either.
It's a tough question, I think.
I don't have the answer. So
I mean, I guess also one way, I think engaging, as you say, is great. And for one part on simply trying out the technology, but secondly, in trying to build up the understanding and the knowledge of people that are not technical people and just, having them. And I think, what Klarna did, they basically, I didn't force employees, but they are measuring how much they are using ChatGPT because they had a special deal with OpenAI and then they can use it for whatever kind of task they're doing for every kind of employee in the company. And in some sense, they are trying to understand or force. I think it's more forcing, but still, I mean, that could be potentially one way in trying to help. Incentivize people to use it.
Yeah, I think, but it's also hard with like AI education as a general. So of course you can try to on a very top-down level say, okay, go this like vidareutbildning and learn about AI. But it also just needs to be like part of your daily workflow, right? It has to come in an if you're not, you have to come in an organic way. So it's
I mean, it's kind of cool that, it's so easy to interact with this kind of large language models. You can do that without having any kind of technical skills at all. It's just, writing some text, uploading some audio or some images, and everyone will understand it, right? It's super simple user.
It's a very good universal interface. But I think, again, just like spread awareness, talk about it, try it out. Yeah. It's not magic.
Isn't it? Cool. Okay, a really philosophical question then. If potentially AGI becomes a reality, what do you think it could potentially create? I mean, some people are speaking about it in if we take the extreme use cases, one extreme use case could be like the really dystopian kind of, Terminator, the Matrix future, where robots are killing humanity, or, which is really bad, I guess, or it could be more of a utopian future where we live in harmony with AI and we are perhaps not forced to work 40 hours per week. We can be more free to pursue the passions, the creativity that we have, and we don't have the need to, earn money in the same way. We still have roof on top of our heads, and we have solved all the energy crisis and the climate issues that we have thanks to AI. Super positive future. What do you think about the future? For one, do you think AGI will happen? Secondly, if so, in which direction?
So I'm super positive towards AI generally, and I think we will build really intelligent machines. And I'm not at all subscribing to this. There is a big doomer narrative out there, and we have some famous Swedes.
Yes. You can say the name.
Yeah, such as Max Tegmark, who is really scaring people, I think. But he's really on the extreme scale. So, no, but I mean, we live in times of change, right? So, and change might hurt. I think we might see some turmoil in the labor market if we get really good AI. But I also think that's short term, and we will have to figure it out. I mean, we will see change regardless from climate and from other external forces. So AI will hopefully really help us along the way, make our lives better. I'm very positive.
And do you have any? I mean, so in the end, there are more to lose by not doing this. There are more things problematic that we need to solve. So let's, to have this sort of AGI threat over here blocking us from doing real stuff here and now.
Yeah,
this is what I'm getting.
But like the doomer movement, they talk about this P-doom, which is like the probability of every human dying. I would say it's absolutely zero. So it's not about that. And then it's like with the printing press. We had some issues when the printing press came, and a bit of social unrest, and that's really problematic, right, on a very concrete level. But I'm still in favor of the printing press.
And the car.
And the car.
Exactly.
And electricity. And having fire.
And the internet. And the transistor.
I'd rather have fire, electricity.
Yeah, exactly.
Awesome. Thank you so very much, Ariel Ekgren, for coming here. It's been a true pleasure, and I'm sure we could continue for a long time more, and we will potentially off camera as well. But it's been a true pleasure to have you here. Thank you so much.
Yeah, thank you for inviting me.
Thank you, Ariel.